So design terms of staircases. There are three technical terms we should know before going to design the staircases. First one is load on stairs. So in that we have to discuss about we have to calculate the dead load. Dead load is nothing but the staircases, the elements, the rise, tread, device, slab, everything we calculate as a dead load. Then second one is live load. We are using the staircases. We are moving up and down. So we are the live loaders. So which is referred from IS 875 part 2. So in that they referred as mentioned as residential building. For the residential building design we have to choose 2 to kilonewton, 2 to 3 kilonewton per meter square. Whereas in case of we are design for a public building we have to choose 5 kilonewton per meter square. This is the condition where we are using the calculate the load from the IS 875. Second one is the effective span. In case let us consider which is referred from the IS 456 class 33.1. They mentioned in the diagram how to choose the effective span of the staircases. This is the staircases. This is the down, this is the up. We are coming from here, then move from here, then reach the up. This one. So this is one landing. This is the stairs. So we are where the flight which occupy the steps we call it as going. Then half of the portion of landing we call it as a x. Remaining half of the portion we consider as the y. So from g plus x plus y, this length we consider as the effective span. In case if it is greater than 1 meter, how to choose? That is the tabulation is there. So let's see, x is less than 1 meter, y is also less than 1 meter. If you half of the portion of the landing width, if you consider x, that x value is less than 1 meter, y value also less than 1 meter, we consider as a g plus x plus y. So in case of width of the beam is 300, what is the x value? 150. Here also width of the beam is 300 means here also 150. Going is approximately 3 meter. So 3 plus 150 plus 150 which will be provide 3.3 meter. So that is the calculation of effective span. So similarly less than 1 meter for x, greater than 1 meter means we have to consider 1 meter. So where it is comes as a greater than 1 meter we have to take it as a 1. So that is g plus x plus y 1. Whereas if it is both x and y is greater than 1 means g plus 1 plus 1. That is the condition we have to keep it remember. Then third one is how the loading is distribution on the stairs. So depends upon the types of spanning. In case of the staircase is supported on the both the landing means we have to take it from the load is transferred on the longitudinally, like that we have to take it as. So depends on the types of spanning only we have to consider how much how we take it as a loadings, how it is distributed we have to take it considering depends upon the types of spanning. So let's see one example of staircases design. We will design the one flight of dog-legged staircases. Let's take a take a look into it. So one of the flight we are going to design. So in the dog-legged stairs, so dog-legged staircase, you know that this is the half of the mid of the floors. From here landing, here also landing. This is the floor, here midway landing. So this is the one flight we are going to design. So number of steps in the flight is 10. Here number of steps is 10. So 10 steps. For the tread distance is 300 mm, rise is 150 mm, width of landing of beams equal to 300 mm. What is the material we are using? Grade of concrete is M20, steel is HOHD bar steel Fe415. So consider this is the dog-legged staircases. Here we are designed for the only one stairs. This one stairs is number of steps is 10. So each steps having a 300 mm. Then rise is 150 mm. So rise is 150 mm. Width of the landing beam is 300. So already explained you. Then now we have to calculate the effective span. So x g plus y. Here 300, here also 300. Number of steps is 10. 10 into 300 we will get the 3000 mm. 3000 mm plus 150 plus 150 we will get the effective span is 3.3 meter. Step number 2, effective span. So effective span is nothing but the number of steps into width plus that half of the landings. So 10 into 300 plus 150 plus 150, we will get the 3300 mm. So that is 3.3 meter. So then next we have to find the waist slab thickness. This is the waist slab. So this portion number 1 we mentioned as a waist slab. So waist slab we simply we taken as a span by 20, which is refers from the IS 456. So span is 3300 divided by 20, we will get the 165. So 165 is the overall depth of the waist slab. So that is capital D, we will get the 165 mm square. So for the calculation purpose, we need to take effective depth D. So we will consider the diameter of the mm is 10 mm. So 10 by 2, then cover is we consider as a 20. So we have to deduct from 165, we will get the effective depth is 140 mm. So next step is load calculation. So we find the effective span and the overall depth and effective depth. Next we have to find the load on the staircases. So what are the loads which is acting on the staircases is nothing but the first number 1 he mentioned as a self height of the slab. That is the first load. Number 2, self height of the steps. Then third one, finish load. Number fourth one, live load. So these are the 4 load we have to calculate in order to go for the design. So next, first we will calculate the waist slab dead load. So dead loads of slab on slope. So it is in slope. First of all, we have to find the slope. Then we will get the exact horizontal load. So dead load of slab on slope. So overall depth into 1 meter into 25, we will get the 4.125 kilonewton per meter for the slopey portion. Not exact load it is a slopey one. So we have to find the exact load on the horizontal. So we have to solve it. So resolve to the horizontal. So dead load of slab on horizontal span. So horizontal span. So WS, this is the load of slopey load, into we have to resolve this length. We have to calculate this length due to that 100 thread plus rise. This is the diagonal portion. We have to calculate this length. So formula is square root of r square plus t square divided by t. We will get it solving by trigonometric formula. So square root of r square plus t square divided by 3. So we will take it as consider this one. So x plus y, here what is the exact distance. So we can easily find it out. This portion considers a z. So z equal to z square equal to x square plus y square. So z equal to square root of x square plus y square. So like that we will easily calculate it. So WS square root of r square plus t square divided by t. So substitute the value here. 4.125 is WS. Then r square is, we know that 150. T square is 300 square divided by 300. We will get the 4.61 kilonewton per meter for the waist slab load. So this is the first one. Then second one, dead load of one step. So dead load of one step is nothing but it is in triangular in shape. So W 1 by 2, that is 0.5 into rise 0.15, thread 0.3, then unit weight of concrete, so 25. So which will get to 0.56 kilonewton per meter. We always design for 1 meter, but it is in 300 mm width only. So load of steps per meter length, 0.56 is a load on one step into for 1 meter design divided by 300 mm width. So we will get the 1.86 kilonewton per meter. So this is the second one, self weight of one step. Then third one, finish load. If in case of if we are applying any tiles or any marbles, we will having some certain load which is assumption. So 0.53 kilonewton per meter. Then fourth one, so we will sum it up 1, 2, 3 because of this is the dead load. We have to sum it up. So 4.61 is the first one, 1.86 is the second one, 0.53 is the third one. So 4.61, 1.86, 0.53, we will get the 7 kilonewton per meter total dead load. Next, live load. Since it is a public building, we will get the 5 kilonewton per meter. So 5 kN per meter. So total service load. So dead load plus live load we call it as a service load. So service load is nothing but 7 plus 5 which is equal to 12 kN per meter. So whenever we design for a limit state, we have to consider as a factor load. So convert it 1.5 times of 12. So that is 18 kN per meter load which is acting on the stair. Step number 4, bending moment. So center of the span only which is acting maximum bending moment. So we will consider the WL square by 8. So here W is our total factored service load, that is 18 kN per meter. Then L is our, we calculated the going plus X plus Y, that is 3.3 meter. So 3.3 square divided by 8, we will get the 24.5 kilonewton meter. So that is our maximum bending moment. We will design for the maximum bending moment only. So now we will check whether our provided by slab 140 mm effective depth which is satisfied or not. So mu limit formula, mu limit which is equal to 0.138 FCK BD square. From the D square we will calculate the D. So substitute all those values, 24.5 into 10 to the power 6 equal to 0.138 into FCK 20 grade of concrete. So B is 1000, then D is D square. So D, by simplifying it, we will get the 94.2 mm enough to withstand this moment. So but we will provide the 140 mm, it is more than sufficient. We provided, hence it is a safe. Next we will provide the main reinforcement. Main reinforcement we will apply this formula. So mu equal to 0.87 into Fy AST D 1 minus Fy AST FCK BD. So substitute all those values, we will get the 530 mm square main reinforcement. We have to provide the following area of steel. So we will take it as a 12 mm dia bar. We can choose 10 mm, 12 mm, whatever it is, but here we choose 12 mm dia bar. We will get the finally 200 mm spacing, center to center spacing, 12 mm main bar, which is satisfy the 565 mm square. We need 530, but we provided the 565 mm square, so it is more than sufficient. Next we will go for a distribution reinforcement, which is 12% or 0.12% of cross section. So 0.12 divided by 100 into B is always designed for 1 meter, so 1000. Overall depth is 165. So 198 mm square. We will provide the 8 mm dia bar. So since it is a distribution reinforcement, we can choose minimum reinforcement 8 mm. So 8 mm dia bar, which is satisfied at the center to center of 200 mm spacing. So let's see the diagram of reinforcement. So this is the staircases. Our slab, landing slab beam is here 300 mm, here also 300 mm. So 10 steps is there. So 150 is rise, that is 300 mm. We provide the main reinforcement at the bottom, that is a 12 mm dia bar, 200 mm spacing, that is your main reinforcement. We provide the bottom. Then over the main reinforcement, we provide the distribution reinforcement, that is 8 mm dia bar. 8 in this 8 is mentioned as 8 mm dia bar. This 200 is mentioned as the center to center spacing. Then one beam to another beam distance only we calculated, that is the 3300 mm. So that is our reinforcement details. So this is the dog leg staircase. We learned how to design for a staircases. In the dog leg staircases, we consider the one flight. We calculated all the overall loads and how the bending moment we calculated, then check for the depth, and finally we provide the reinforcement for the maximum bending moment. So this is the detailed of staircases design. Thank you all.